Today we're going to be talking about two-dimensional arrays. Now, let's start off by considering the array we have on screen right now. It's a size 10 array of integers. Now, a common question I get is, can you make arrays out of different variable types? And the answer to that is yes, of course you can. You can make arrays out of chars, strings, integers, like whatever you want. Well, hold on a second. If you can make arrays out of strings, well, aren't strings objects? Well, does that mean you can make arrays of objects? Well, yes, it does. That actually leads to an interesting question is, can you make an array out of an array? And the answer to that is still a yes. You can make arrays out of arrays. And so the way you do that is like this. Okay, so here I have an array, but I'm going to make an array of arrays, right? And so in this case, let's do this one. We'll make it 10 by 20. All right, so what I have here is an array of arrays, also known as a two-dimensional array. Now, it's important to know that we have to actually provide the dimensions for those arrays. Okay, so you can't just have it like undefined like that, right? It's probably going to give you an error, but nonetheless, we're going to define it as that. Now, how do you use this? This is actually kind of a weird topic, right? Because how do you actually use something that's in a two-dimensional array? Well, the key to it is actually kind of just to view it as something like a Cartesian coordinate system, right? Where you have your X and Y addresses. So whereas before you had basically a line with each index corresponding to an element in the line. Now we have an X and a Y value, and those ones are going to correspond to the X and Y values in the array. So the key to using this is to use actually a nested loop. So we're going to say for int x is equal to 0, x is less than, we'll say 10, x plus plus. All right, and then we can also say for int y is equal to 0, y is less than 20, y plus plus. And then let's say, for instance, we wanted to just show all the values. So we can say system.println numbers at x, y plus a space. And we'll get rid of the line part. There we go. You can see right now it's all zeros, obviously because we haven't populated the array. Well, let's go ahead and actually populate the array. Okay, so I'm going to copy my loop over here. Now, I know I could actually do it all in one row or in one algorithm, but I'm going to actually separate it just for convenience here, just to make it so people can see like what section I'm doing what in. Okay, so populating the array. And what I will do is I will just assign each value to have a random number from 1 to 100. So numbers at x, y is equal to math.random times 100. All right, so just something simple like that. Okay, times 100, and I feel like my brackets are a little bit off, and they are. There we go. Okay, and so you can see we have actually an array of random numbers. Now, the problem with this is it's just this huge long line of random numbers, so it's actually hard to tell what's in each row or whatever. So after we print the whole row, so this is going to be actually row 1, and then what we're going to do is we'll say this is the rows, which makes this one controlling the columns. Okay, so basically we have going to our first row, print out every item in the column, and then once we print out every item in the column, we are just going to have an end line. Right, and you can see it's just like this. Now, we can actually make this a little bit nicer, okay, by just making the print line. Now, the reason why it's not all in a nice grid is just because this is actually, there's some numbers that are a single digit and some that are double, so we can just fix that really quickly. So we can say if numbers at x, y is less than 10, then we're going to print it with 2 spaces. And otherwise, we just print it with 1 space. Okay, and there you go. We have a nice grid of numbers, and this should be 200 numbers, right? So 20 by 10. So let's see, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, and going up, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, an important thing to make note of is that unlike a Cartesian coordinate system, the x values are actually going down and the y values are going across. Now, I found that some people, they often try and reverse the x and y, so the x goes across and the y goes down, and you can do that, but I found overall it just makes things a little more complicated and it's generally not worth it, right? It's just better just to remember the x is going down, the y is going across. Right now, a common question I get is, can you do even more than 2 dimensions? Well, yes, you absolutely can do more than 2 dimensions, right? So how would you do that? Well, if you wanted 3 dimensions, well, you just add 3 dimensions. So you could do this like so, right? And you can have 4 dimensions and 5 dimensions, as many dimensions as technically you want, right? Now, as for visualizing it, I've actually come up with a decent way of visualizing it. A one-dimensional array can be visualized as basically a line, right? So in a line of boxes. In a two-dimensional array, it's basically a grid of boxes, and you go to x and y coordinates, and you open up that box, and you find whatever value you're looking for. For a three-dimensional array, it's like a cube or a rectangular prism stacked of boxes. So you go x, y, and then z, and then you open up that box, and that's the value. Okay, but what about a 4-dimensional array? Right? Well, we don't live in 4 dimensions, and so it's actually very difficult for us to visualize that. But the way you can visualize it is you start off with your 3-dimensional array, right? So that's your rectangular prism of boxes, and so you go x, y, z, and then you open up the box, and inside is another array. And then you have to go one more dimension in. For 5 dimensions, it would be the same thing. So you go x, y, z, and then you open up that box, and there's a grid inside, and you have to go A, B to get into the spot you want, right? And then for 6 dimensions, it would be the rectangular prism. You go x, y, z, and then you open it up, and there's another rectangular prism. You have to go A, B, C to get to that. And then once you go 7, then you go, it's a prism, and a line, and so on and so forth. Right? So you can see, like, if you just keep visualizing it like that, it makes it a little more easy to kind of picture it in your head, at least as a physical model. So that's pretty much the basics of using a 2-dimensional array. It's just important to be careful that you don't mix up the dimensions, because otherwise you may go out of bounds and end up with some errors. Right? It's also another last thing is that it's important to remember that this is an array of arrays. So if you had a method, for instance, that needed an array, okay, so let's say I had like something like this, public static void display, and all this does is just display an integer array. Okay, and in order to display an integer array, what I'd have to do is I'd have to say for int x is equal to 0, x is less than array dot size or length x plus plus, and then just do a system out print line, just print array at x plus a space. Okay, and at the end I'll just do a print line. Okay, well, let's say, for instance, I wanted to display this, I want to use this method. Well, this method takes a 1-dimensional array, but down here I've got 2-dimensional arrays. So what I have is actually a system of, it's a set of arrays, it's an array of arrays. So I can still use this, I would just have to pass it line by line. So for instance, I could say display numbers at 0, like that. And that should just display just the top row, right? Like that. Okay, and actually, let's put this back in so we can see the whole thing. So up here, we will be showing the entire array. And then on the bottom one, I'll just show the display here and see what we got. So we got 60, 93, 17, 48, and you can see up here I only passed just the top row, right? Because that's just one array. All right. Well, could I actually pass another one? Of course, I could, for instance, pass row 5. Right, so this is 0, 1, 2, 3, 4, 5. That starts at 41. And down here, you can see this is the row starting at 41. Now, could you pass an entire column? Right, and the answer to that question is no. And the reason why is because this is an array of arrays. Okay, so here is one of the arrays. The array is actually going down like this. But in each array section, so this is array at 0, there inside this is the whole other array. Inside here is another array like this. It's not like this, that this is a single element within an array, but it does not go down. It actually just goes across. All right, so in any case, that's pretty much it. If I wanted to pass a two-dimensional array to a method, it would be a very similar thing as passing a single dimension array. Just add the extra dimension, and then here I would have to add the two dimensions to the array as well, right? So for instance, if I did like 5, 7 or something like that, then it would work. All right. Oh, actually, sorry, not like that. I would have to just do it like that, just to say here is the whole two-dimensional array. All right, that's pretty much it. If you have any questions, remember to leave a comment. Remember to like and subscribe to the channel. Thanks for watching, and I'll see you next video.